The points A, minus 1, 2, B, minus 3, minus 4, C, 3, minus 6, and D, 5, 0 are the vertices of a square. The vertices are just the corners. The sides of the square are tangents to the circle S as shown. Find the coordinates of the center of circle S. So this circle is called S, and we want to find the coordinates of the center. So here's a picture of this rectangle here. A has coordinates minus 1, 2, so we go to minus 1 on our x-axis and just go up plus 2 units on the y-axis, and we have the point A. The point B has coordinates minus 3, minus 4, so we go to minus 3 on the x-axis, which is here, and we go down to minus 4. 3 minus 6, that's point C, we go to plus 3 on the x-axis and down to minus 6. D has coordinates 5, 0, so we go out 5 units on the x-axis and up 0 units on the up or down 0 units on the y-axis. So D is a point on the x-axis. So if you draw a diagram fairly accurately, you could probably work out the center just by construction. What you would need to do is draw in one diagonal. So draw in one diagonal and then bisect that diagonal. So you just want to get half the length of this diagonal, so that this distance equals this distance. So you could just measure it maybe and half that measurement, and that'll give you the center. You could also bisect this line using a compass. What you could do is draw a line to show, just to explain how to bisect a line using a compass. Put a compass point at one end of the line segment, so we put compass point at B, extend the compass to a distance that's greater than more than half the length of this line, and we just draw part of a circle. Then with the same compass extension we put the compass point here and draw in like this, and what we do then is just join up the intersection of these two arcs, and this point will be the midpoint of the line segment. This distance will equal this distance. So that's one way you could do it by construction. A better way to do it is simply to get the midpoint of this line. So you can use your midpoint formula to do that. Another thing you could do is just draw in the horizontal distance between the 2 points, and here's the vertical distance, and just say get the midpoint of either the horizontal or the vertical distances. That's easy to do. You don't need any compass to do that. So we have this vertical distance here is 4. You just count the squares. Well, each square here represents 2 units actually, but on your diagram we would have 4 squares because this point has y value minus 4, so this distance here would be 4 unit squares down. So to get the midpoint we'd have to go down a distance of 2 squares, and we get to this point, and then you just project across and there's the midpoint of the line. Or we could bisect this horizontal distance. The total horizontal distance here, if we just count the squares, we have 5 squares from here to here, and 3 squares from here to here. So that's 8, a distance of 8, and half of 8 is 4. So you just go count across a distance of 4, and just goes vertically up, and you'll hit the center of the line. Okay, so you can quite easily do it from your graph paper. If you don't have any diagram, what you do is you look at the coordinates of the 2 points, and the midpoint is straightforward to get. You just add the x values and divide by 2. You get the average of the x values. Add the 2 numbers and divide by 2. Get average of the y values, or the mean of the y values. It's not just any old average, it's actually the mean of x values and mean of y values. This formula is x1 plus x2 over 2, comma y1 plus y2 over 2. And we get minus 3 plus 5 is plus 2 divided by 2 is 1. Minus 4 plus 0 is minus 4 divided by plus 2 is minus 2. So the center has coordinates 1, minus 2. So the midpoint of the diagonal is also the center of the circle that's inscribed in this square. In part 2 we have to get the equation of a circle. You need 2 things for the equation of a circle. You need the center, which we have, it's 1 minus 2. And you need the radius. The center is called HK. h comma k. H comes before k in the alphabet. So h is the x value of the center. K is the y value of the center. What's the radius of this circle here? Well, we could do that in a number of ways. We could get the distance from the center to the point D. That's one way to do it. The center, well, sorry, that's not one way to do it. D is not on the circle. We could get the distance of the center to, say, point E. Where E is the midpoint of the line AD. Alright, so the distance of the center to point H, where H is the midpoint of DC, or the distance of the center to point R, where R is the midpoint of BC. Okay, so we have plenty of choice. So let's get the coordinates of point E. So E is the midpoint of the line joining A and D. So we could do that from our diagram. You know, you could just draw down a vertical distance between the points A and D. This vertical distance here, bisect it, and just go across and read off the coordinates, but I won't do it that way. I'll use the formula. To get the midpoint of a line segment, we get the mean of the average, the mean of the x values. So we have minus 1 plus 5 divided by 2. And the mean of the y values, which is 2 plus 0 divided by 2. Or x1 plus x2 over 2, y1 plus y2 over 2. And we've minus 1 plus 5 is plus 4 divided by 2 is 2. We have 2 divided by 2 is 1. So E has coordinates 2, 1. And you can check on your diagram as well. If you draw your diagram, if you draw in a diagram fairly accurately, you can check to see that it makes sense. This looks right. The x value of E is 2. The y value of E is 1. So now we get the distance of the center to the point E. Now we can do that in two ways. We can use a formula, or we can just do it by looking at a right angled triangle whose hypotenuse is the line joining the center to the point E. So I just do it by looking at this diagram. So we want the distance from the center to the point E. That's this yellow distance here, or well, this blue distance now. What we do is we get the two short sides of this right angled triangle and use Pythagoras' theorem to get the longest side. So what's the distance from here to here? Well, the x value of E is 2, so it's 2 minus the x value of this point, which is 1. So this distance is 1. 2 minus 1 is 1. And the vertical distance is, you can just count the squares on your diagram. So we're going from plus a y value of plus 1 down to a y value of minus 2. So we're going from plus 1 down to minus 2. That's a distance of 3. So we have a right angled triangle whose short sides are 1 and 3. So the distance between the 2 points, I'll call it D, actually I'll call it R, because it's the radius of the circle. We have that R is the square root of the sum of the squares of the two short sides. So that's root 1 plus 9, or root 10. Of course, we could have used the distance formula. You could write down the 2 points, minus 1, 2, label them x1, y1, and the other point is 2, 1. Label it x2, y2, and then plug them into this formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. So that's R. This is really just coming from Pythagoras' theorem. You know, the fact that the square of the hypotenuse, R squared, is the sum of the squares of the two short sides. Or R is the square root of the sum of the squares of the two short sides. So if you plug these values into this, you'll end up with root 1 squared. This will be 1 anyway. Both of these will come out to be positive. You end up with root 1 plus 9, which is root 10. Here's the formula for the equation of a circle. Actually, this formula comes from Pythagoras' theorem as well. xy is any point on the circle. hk is the center. R is the distance between those 2 points. And the distance between them is always is a constant. It's always equal to R. So this is just an application of Pythagoras' theorem. I go into this in another video, so I won't repeat it here. You can just look this up or memorize it and plug in for the center and the radius. So the center is hk. So we get x minus h, which is 1, squared, plus, copy down y minus k. K is minus 2. So it's minus minus 2 becomes plus 2. We square that, equals r squared, root 10 squared. Root 10 squared is just 10. So you can just write 10 here. So this is the equation of the circle S. That's that part done, but just as a bit extra, what I will do is I will check to see that the point 2, 1 is on the circle. So let's look at the point 2, 1 and sub it into the equation of the circle. Okay, that's the point E. That's the point E on the circle. This point here, it's definitely on the circle. So let's just see that the point 2, 1 satisfies this. This is just something extra. So we plug 2 in for X, plug 1 in for Y, and copy everything out. And when we work out this, we should get 10. 2 minus 1 is 1. 1 squared is 1. 1 plus 2 is 3. 3 squared is 9. So that does indeed check out. So that's a good sign. Well, it's right anyway, but any point on the circle should satisfy the equation of a circle. That's the meaning of the equation of a circle. In part 3, we're given that the circle x plus 4 squared plus y squared equals 10 is the image of circle S. Under the translation, PQ maps onto the point 6, 5. Find the value of P and the value of Q. So let's look at this second circle, x plus 4 squared plus y squared equals 10. Now, if we wanted to draw a rough sketch of it, what would we have to do? We'd have to get the center. So we'd have to compare it to the general form of a circle. The general form of a circle looks like this: x minus h squared plus y minus k squared equals r squared. We just compare it to this here. So okay, this is something you just look up or memorize. So we can see that the number after x, the term after x, is minus h. That's minus the x value of the center. The x value of the center is h. So if we want to find out the x value of the center, we compare to this here. So we see that minus h equals plus 4. So h must equal minus 4. So basically you just take this number that comes after x and change its sign, and that gives you the x value of the center. We can see a picture here. The x value of the center is minus 4. We do the same for our y minus k squared part. We look at this here, minus k, and we compare it to what comes after y. Well, actually 0 comes after y here. Minus k equals 0, or k equals 0. Okay, if we change the sign, it doesn't matter, it's still 0. We could actually write y squared as y minus 0 squared, or y plus 0 squared. Same thing, y minus 0 is just y, or y plus 0 is y. So minus k equals 0. So the center of this new circle is hk. H is minus 4, k is 0. You won't forget that h comes before k, just like in the alphabet. So h is the x value of the center. K is the y value. So we plot the point minus 4, 0. So we go to minus 4 on the x-axis. Y is 0, so we're not up or down 0. So it's a point on the x-axis. What about the radius of this circle? Well, we just compare r squared to this number here. R squared equals 10, so r is the square root of 10. So the radius of this new circle is the same as the radius of the old circle, root 10. That's what we got for the radius of the old circle. Here's circle S. That's the old circle. Its radius is the square root of 10 also. That makes sense because this new circle, this dotted circle, is the image of the old circle under a translation. Translation preserves shape. If we move an object under a translation, its size doesn't change. So the radius of this circle under a translation should stay the same. So we're given that this new circle, this dotted circle, is the image of circle S. That's our old circle. Under the translation, PQ goes to the point 6, 5. Now where's the point 6, 5? That's out 6 and up 5. It's actually off this diagram. It's somewhere up here. I can't draw that accurately, but x is 6 and y is 5. It's probably not up that far. It's probably about here. Yeah, we have 2, 4. This would be the point 65. And PQ then is some point. It's the tail of our translation. This point here, 65, is the head of the translation. So you can see that the circle moves in this direction here. So the center of S ends up on the center of our new circle. So the translation is actually this arrow here. We can move a translation around as long as we don't change its size. Move it around parallel to itself. Keep the arrow pointing in the same direction and keep the arrow having the same length. So you could imagine moving this here. So we'd have a new arrow. This is our translation, by the way. The tail is PQ and the head is 65. So the idea is that this translation takes circle S and maps it onto our new circle. So we'd move circle S in the same direction as this arrow, which is this way, and we'd move it the same distance as the length of this arrow. So in other words, the center of S gets mapped onto this such that the distance between the centers is the same as the length of this translation. So this arrow and this arrow are essentially identical. They're also sometimes called vectors. Well, a vector is a more general name for it actually. It's not a name that we use here, we just call them translations. So how do we find the coordinates of this point here? Well, we just compare the line joining the centers with this line, and we look at the right angle triangle formed. So we could just measure the two short sides of this right angle triangle and then construct the same right angle triangle on this translation here. So this distance here is 2. That's the vertical distance between the 2 points. See, we're at 2 here. Just count the squares. And if we count from here to here, we're going from -4 to 0, and we're adding on 2. So this distance is going to be 6. So what we do is we go to the point 65 on our diagram, and we draw down a distance of 2. And then we go across a distance of 6. And then we can just read off what this point is. So that's one way to do it. This triangle here and this right angle, these two triangles are congruent. So we can also work it out without drawing this out accurately, because I know that this horizontal distance is 6. So if I take our x value of this point and just subtract 6, add 6, because we're going to the right 6 units. We're going 6 units across here. So the x value of this point P must equal this number here, the x value of the head, 6, plus this distance here, which is 6. So that gives us 12. Spotted a mistake here. This distance is 5. I just counted this wrong. I was looking at this point actually. We want the distance between these 2 points is 5. So what we have to do is take 6 and add 5 to get P. So we get 6 plus 5 is 11. So the x value of this point is 11. What about the y value? Well, the y value is 5, and you can see that the y value decreases by 2. So q equals 5 minus 2, which is 3. So the point PQ has coordinates 11, 3.